Hello everyone. Welcome to the sixth tutorial session of Probability Foundation for Electrical Engineer, and who is instructor Professor Krishna Jagannathan from IIT Madras. And this is the sixth tutorial session, and I am Satyavikram Pratap Singh, a PMRF research scholar at Department of Energy Science and Engineering, IIT Bombay. So in this tutorial session, we will see few of the problems which will help you to solve the assignment 7, and this is the problems which is related to the normal distribution and the CDF and probability foundations and all. So let's move forward and see the first problem. I will give you a few of the minutes to read the problem, and after that try to solve it by yourself if you know the that basic concept. And if you don't, just let me know and I will make sure that I will clear the concept and get to you the final solution. Okay, this is the first problem. Try to solve this. Okay, let me give the solution for this. What is asking that let x y be the exponential of 1, defining the u is equal to x plus y and v is equal to x divided by x plus y. It is asking what is the support of uv is. Either u is greater than 0, v is greater than 0, or u is greater than 0 and v lies belonging to the v belonging to the 0 to 1. Okay, and or you can say that if you see v belonging to in between minus 1 to 1. Okay, and either v is equal to u plus 1v. So when you see that key, what is the first step by step we will move forward. So here if you see that key, if it is given that key this is an exponential of 1, it means that key x is greater than 0 and y is greater than 0, and defining what is given as u is equal to x plus y and v is equal to x divided by x plus y. Let's invert it means when you keep the values intact and put the values that x is equal to uv and y is equal to u1 minus v. So when you map the domain because xy is already greater than or equal to 0, so x plus y will be greater than 0 when you sum it up. Okay, so because minus uv get cancelled out and the u will remain and u will be greater than 0 because x plus y is greater than 0. And then similarly the fashion, when you see that, so for a density that is interior points, take the u is greater than 0 and v is greater than 0. And this is the thing that when you find out the Jacobian, means del xy with respect to that, del xy del u, del x by del v, del y by del u, and del y by del v. Okay, when you find out the Jacobian, it will be simply u will come. So in that fashion you can say that joint probability is something which is supported by the u greater than 0 and v is 0 to 1, and also the function of uv, that is the u e minus v, that is simply the integral over the 1. So the option b will be the correct. Here also we have finding out that u is greater than 0 and v belonging to 0 to 1, but Jacobian is coming u, so that's why we are feeling that u is greater than 0 and v is between the 0 to 1. Okay, let's move forward, try to solve this problem. you're facing any problem, just let me know. Okay, let me give the solution for this. When you see that keyword is saying that key, that is simpler fashion, the exponential of 1, and it is asking what is Jacobian, del of it, which we have already found it out, if you remember this here. Okay, here. But let's solve it again. Okay. So u is what is given, that u is equal to x plus y, and what is given, that's v is equal to x divided by x plus y. Okay, that's fine. Okay, let's invert it. When you invert the both the equation, let's invert it. How to invert that? Okay, when you see that kx plus y is actually u, put it in the second equation. So v is equal to x divided by u, so x will become uv. Okay, put it in the first equation here. So y will be equal to u minus x. What is x? X is equal to u minus uv, that is u1 minus v. Okay, so let's find the Jacobian. Jacobian is simply is equal to del xy del uv. When you find it out, then it will be simply equal to del x by del u, del x by del v, here del y by del u, and del y by del v. Okay, let's solve it. When you solve the del x by del u, it will become v. Del x by del v simply u. Del y by del u, that is 1 minus v. Del y by del v, that is simply equal to minus u. Okay, when you solve it, because the determinant it is asking, so when you solve this determinant, it will become minus vu minus u 1 minus v. Solve it, minus vu minus u minus vu, u cancel out, minus u. When you take mod of it, it will become u. Okay, so simply the correct answer is option B. Okay, let's move forward, try to solve this question. Okay, let me give the solution for this. What is asking that ki a joint density of f uv and vu. Let's solve it. When you see the function is already means ki it is given that ki f x y is equal to e to the power minus x plus y, and that is x is greater than 0 and y is greater than 0. U is given that x plus y and v is divided by x plus y. Okay, and x is equal to uv. When you transform it, then you will get, and the similar fashion we have already solved the Jacobian, you we get u. Okay, let's solve the with respect to uv, that is a function which we wanted to find it out. When you see that fxy is equal to fxy uv u1 minus v, when you find out the Jacobian of this by transforming, because e to the power minus x plus y is there. So when you put the value of this, x is equal to uv and y is equal to u1 minus v, and what is the value of fxy x comma y xy is equal to e to the power minus x plus y. Okay, put the value e to the power minus what is x, x is uv plus y u minus uv. When you solve it, e to the power minus u. Okay, and okay fxy. Okay, what is Jacobian? When you find out the value of f of uv at u comma v, it will be simply equal to f xy uv dot Jacobian. When you, what is Jacobian? U is u e to power minus u. What is the answer? That is the u minus y. What is the correct answer? That is option B. Okay, u greater than 0, and we bounded reasons of this u greater than 0 we have already defined in the first problem. Okay, any problem in this? If you feel any problem, just let me know. Okay, try to solve this problem. That is similar function, that density function. The only thing is that you have to put the value and get the answer. Okay, try to solve this. We will go by this step by step procedure, but try to solve this. Okay. Okay, let me give the solution because it's a very simple problem, and we have already derived the value of this f uv which is equal to u e to the power minus u, u e to the power minus u greater than 0 and v is belonging to the 0 to 1. Okay, let's put the value because what we needed that is f uv 2 comma point 0.5. Okay, so put the value because u e to the power minus u. So this is u, this is v. U is 2, e to the power minus u means e to the power minus 2. When you solve it, it will come to 70670, which is exactly matching with the option B. Okay, okay. Let's move forward and try to solve this problem. No, the lecture is going on. Okay, let me give the solution for this. When you see that that similar kind of problem which we have solved previously, and here v is given x divided by x plus y, and it is asking that what is the marginal distribution of v. Let's solve it. When you see that because u is already in the previous question we have defined u is equal to x plus y and v is equal to x divided by x plus y. Okay, and fuv we have already calculated, that is u e to power minus u from here. Okay, so when you see here and u is greater than 0 and v is belonging to in between 0 to 1. Okay, open interval. Okay, so So when you see that key, what is the value of FVU? VV, okay, because it's a single probability you want, okay, single density. FUV UV DU, okay. When you solve it 0 to infinity, U it is power minus U, du is equal to, so when you solve it, it will come out to be 1, okay. Just solve it, you will get the inform. So it's a kind of key 1, in V is belonging in between 0 to 1, and it's a uniform, value is 1, okay, because the density is coming out to be 1, okay. So that's a uniform variable in between 0 to 1, so correct answer is option A, okay. Let's move forward and try to solve this. Okay, let me give the solution for this. When you see that u is already given that x plus y, v is equal to this, and vu is independent. Okay, it is asking whether they are independent or not. Let's find it out. Okay, how to say that whether they are independent? Just you have to find it out. F u of u and f of v of v. Okay, if those values, when you find it out, if both are equal, okay, then they are, if the value, when you say that when these values are equal, then you can say that they are actually independent, dependent. Okay, when their values are unequal, you can say that they are not dependent. Okay, they are independent basically. Okay, let's find it out. F u is 0 to 1, u e to the power minus u dv. When you find it out, u e to the power minus u, it will come. Okay, when you find it out, the value of f u v u, u e to the power minus u du, okay, it will come out to be 1. Okay, both values are not equal, but it is simply that if you see u e to the power minus u, but when you say that what, if they are independent, it means that u v u comma v will be equal to f of u dot f of v of v. Okay, when you multiply both, and that is equal to a similarly that density function, that is simply equal to what it is. It came at u e to the power minus u. What is this? This is 1. And similarly it is also came, that is this. So both are equal, so it means that they are independent. Okay, yes, option A is correct. Let's move forward, try to solve this problem. You have to find it out, probability of p x is greater than y. Okay, let me give the solution for this. What are you asking in this, that the probability of px greater than y equals, okay, when you see that that p is equal to y greater than 0 and px is equal to y greater than 0, so because it's a continuous symmetry, then you can say that if it is a continuous symmetry is there, so it means that because x is equal to y, it will be equal to 0. Okay, so it means that ki p exit y will be the half of value, that is half and half, point 0.5. Okay, you can check it by integration also, means probability of x greater than y is equal to 0 to infinity probability of x greater than y f of y dy. Okay, put the value 0 to infinity. What is the value of x greater than y? That is simply equal to e to the power minus y, because when you see here exponential of 1, e to the power minus y, and then dot e to the power minus y dy is equal to e to the power minus 2y, 0 to infinity. When you solve it, dy get zero point 0.5. Okay, you can directly confirm with it. Okay, so correct answer is c, zero point 0.5. Okay, try to solve this problem. Okay, let me give the solution for this. When you see it is asking that let x, y be jointly normal within 0, unit variance and correlation rho belonging to minus to 1. What is asking that define z is equal to y minus rho x under root 1 minus rho square. Okay, then asking that x and z are independent in the normal uh, and x y are correlated but not dependent independent. Z belonging to normal distribution in between 0 to 2. Okay, independence hold only when rho is equal to 0. Okay, so when you see that it is asking x and z are independent, normally defined in between 0 to 1, xy is jointly normal, ex is equal to ey is equal to 0, and variance x is equal to variance y is equal to 1. When you find out a correlation between xy, that is simply defining rho belonging to minus 1, it is defined as like this: z is equal to y minus rho x under root 1 minus rho square. Okay, ez mean of z is equal to ey minus rho of ex. When you put the value y x here and simply compute, it will become 0. So what is the variance of z? Variance of z is variance of y minus rho y, because it's a constant. So it will become variance of y, that is 1 plus rho square minus 2 times of rho convolution of x and y. Okay, put the value of this here, it will become, because it will come out to be rho. So 1 minus rho square minus 2 rho square will come out to be 1 minus rho square by 1 minus rho square equal to 1. That is simply is the normal distribution between the 0 to 1. If you say the uncorrelation with the x, that is simply equal to a correlation of x y minus rho x root 1 minus rho square. With the put the value here, the correlation between rho dot 1, that is 1 minus rho square, it will come out to be 0. Okay, so the correct option is A, because x and z are independent in n is equal n belonging to 0 to 1. Okay, okay, try to solve this problem. Okay, let me give the solution for this. It is asking that x, y, whatever was there in the previous problem, and it is asking what a correlation between covariance of COV that x z. So that is z is equal to y minus rho x root 1 minus rho square, which is already defined in the previous problem. Covariance of xy is rho and variance of x is 1 from the previous problem. And covariance of xz is covariance of x comma 1 minus rho x, because z is already been defined by this. So that is 1 minus rho square because it's constant. Rho covariance of xy minus rho of variance of x 1 minus rho square. When you put the value, covariance of is there and here, that is equal to 1. Okay, it will come out to be 0. Okay, correct answer is option A. Let's move forward, try to solve this. Here it is asking the distribution object. Okay, that is not a straightforward problem, but it's a easy one. Okay, let me give the solution for this. When you see that it is asking let x, y be same as the question, what is there? It is asking distribution of z. Okay. When you see that, because it's a linear transform, normalize it. Z is a normal. Okay. Ez is equal to ey minus rho of ex divided by rho 1 minus rho square. Okay. So this we have already, when you see a correlation between x z, that is actually 0. So here, if you see, find it out, Ez is equal to 0 here because it's a normal distribution is there. So that's why Ey here, Ex is 1, Ey is rho, so that's why it is 0. So variance of Z, when you find it out, variance of y minus rho x divided by 1 minus rho square. So 1 plus rho square minus 2 times of rho covariance of x plus y, or x comma y. Covariance of x comma y, it is already been defined that it will be rho. We have computed that. Okay, 1 plus rho square minus 2 rho square is it will come out to be 1. So that is n 0 to 1. Okay, let's move forward. Try to solve this problem. Here arc of sine means sine of inverse. Okay, let me give the solution for this. It is asking when the x and y be the standard bivariate normal with the correlation rho, the quadrant that probability p x greater than 0, y greater than 0 will be equals. Okay. When you see that by the standard bivariate normal with the correlation of rho by symmetry, p is p probability of x greater than 0, y greater than 0 is equal to equal to probability of x greater less than 0 or y less than 0. That is simply equal to means q, and that is p x greater than 0 and p x less than 0, that is simply equal to, when you say that, it's r. Okay, so hence 2q plus 2r is equal to 1, and you can say that q plus r is equal to half. For jointly normal x and y, that expectation of sigma sine of x and the sine of y, that is simply equal to by pi sine inverse of rho. That is a separate formula using that. Okay, put the value when you see that q plus minus r, that is equal to 4q minus 1. Similarly, when you solve for the q, because q we have already defined here, that is p x greater than 0 and y greater than 0. So 4q minus 1 is equal to 2 by pi sine inverse of rho. Okay, get the value of q, what it will be, the 4 is equal to 1 plus 2 by pi sine inverse of rho. Q is equal to 1 by 4 plus 2, or you can say that 1 upon 2 pi sine inverse of rho. Okay, so that is the value of q. What it is coming, 1 by 4, 1 upon 2 pi, 1 by 4, 1 upon 2. Option B is actually correct. Okay, let's move forward, try to solve this problem. Okay, let me give the solution for this. It is saying that let x y be the standard bivariate normal with correlation of rho. Then what is the value of limit rho tends to 1, probability of x greater than 0 comma y greater than 0 is equal to. Okay, let's solve it. When you see that we have already calculated that probability of x greater than 0 comma y greater than 0 is equal to 1 by 4 times of, because it was q, and sine inverse of rho. Okay, what is asking here? Limit rho tends to 1. Okay, if limit rho tends to 1 and this value, suppose this is let's take it small z, z. So when you put the value here 1, it will become 1 by 4 1 upon 2 pi sine inverse of 1. What is sine inverse 1? Is actually pi by 2. Okay, so when you put the value 1 by 4 1 upon 2 pi multiplied by pi by 2, it will simply come out to be 1 by 4 plus 1 by 4 is equal to 2 by 4, that is 1 by 2, that is equal to zero point 0.5. So which option is actually matching? Option C. Okay, it's an easy problem, but you have to understand the way how to solve it. Okay, okay, option C is correct. Let's move forward, try to solve this problem. Okay, let me give the solution for this. It is asking on 0 to 1, Lebesgue measure define that x omega is equal to 5, omega is greater than 1 by 3, and x omega is equal to 3. If omega is less than or equal to 1 by 3, then the equation expectation of x is equal to. When you solve it, because it is given that probability of omega greater than 1 by 3, and it also says that key, let's write it down here. It is saying that probability when omega is less than or equal to 1 by 3 is equal to 1 by 3. Good. When omega is greater than 1 by 3, its probability as 2 by 3. Okay. In between 0 to 1. Okay. What is asking? It is asking that what is expectation of x? Expectation of x. Okay. So how to solve it? Okay. So expectation of x will be simply equal to area. Area means, let's define it. Define it how? Omega 1 by 3 is the boundary. Okay. X omega less than 1 by 3, it is omega, this is probability then. Okay. P defining less than equal to, it's simply equal to 1 by 3. Okay. Fine. Omega greater than 1 by 3, it's a 2 by 3. Let's define it. Okay. And in between 0 to 1, so here it is not there, it's between the 0 to 1 only. Okay. So what will be the total area currently here? Here like this. Okay. So what is the expectation of one? Simply the area. Try to find it out. Is this 1 by 3? This is also 1 by 3. Okay. 2 by 3, that is equal to 5. But the values are given different. Okay. X is equal to 3. Sorry. X is equal to 3 here, and here it is given x equal to 5. Okay. Fine. Expectation of x is 3 multiplied by 1 by 3. Okay. Plus 5 multiplied by 2 by 3. Okay. So when you solve it, it will come out to be 1 plus 10 by 3, or you can say that 15 by 3, or you can say that 3, 4, 12, 3, kind of. 13 by 3 is the correct answer. Okay, let's move forward, try to solve this problem. Well, let me give the solution of this. It is asking that कि when we have to find out the expectation of y omega is defined as w belonging to q is 2, w half is equal to 4. When it is not q and less than or equal to 4 is equal to root 6, write otherwise. Okay. When you solve it, it is simply equal to that what it is asking expectation of y. Expectation of y. Okay. So if you see that lambda q in the intersection of 0 to 1, because some of the values which are off the record, which is, so you need the value in between 0 to 1. Some value will come from here, some value come from here. Okay. So when you see that root 6 and root 8, these values. Okay. So the intersection point, when you see that lambda of q and 0 to 1, that is 0, and lambda half is equal to 0, because the value 2 and 4 doesn't affect the expectation of y. So which affects actually, that is root 6 and 8. So when you plot it, it is simply 0 to 1, and this is 1 by 4. Here it is simply root 6. Okay. And this is 8. Okay. It is root 6 multiplied by 1 by 4 plus 8 multiplied by 1 minus 1 by 4, that is 3 by 4. When you solve, it will come out to be root 6 by 4 plus 6, or simply you can find it out, it will come out to be nearly 6.6123. So the option B is actually correct. Okay. Okay. Any problem? Okay, let's move forward. Try to solve this problem. Okay, let's solve this problem. It is saying that on 0 to 1, you have to compute 0 to 1, 1 QW, that is dW. So when you say that integrand, that one is a integrator of the rationals in 0 to 1. Okay. So when you measure the fact that Q is and this intersection of 0 to 1, that is actually 0. There is nothing which is belonging in between both. Okay. And when you take the 0 to 1 such that the q is equal to 1, and when you find out the integral, that is 0 to 1, 1 qw dw is simply equal to lambda of q intersection on between 0 to 1, which is equal to 0. Okay, so the correct option is option B. Okay, let's move forward, try to solve this problem. In this problem, it is saying that let f comma g be a simple finite valued measurable function on a measurable space, which is always a simple function, either f plus g, fg, maximum of fg, or all of the above. Okay, try to solve this. Okay, let me give the solution for this. So it is asking f and g be simple function on a measurable space, which is always a simple function. So it is asking which is always a simple function, f plus g or fg or maximum of fg or all of the above. Let's go step by step. When you say the range of f, that is alpha 1 to alpha n, and range of g will be beta 1 to beta 2. Let assume that. And f plus g is the simple. Okay, range of f plus g is belonging to alpha I plus beta j, I belonging to 1 m to 1, and j belonging to 1 to n. This is a finite set, miserably follows with the miserability of the f and g. What about the fg? Fg is also simple. When you multiply it, that is alpha I beta j, and I belonging to in between m 1 to m, 1 to m, and j belonging to 1 plus n. This is also a finite miserable. Okay, when you say ki range of maximum fg, that is belonging to all the ranges alpha 1 to alpha m and beta 1 to beta m, that is also a finite measurable space. Since when you take the maximum of fg, that is equal to half of the f plus g plus f minus g, mod of f minus g, that is sums absolute value, that also preserve measurability. When you see that ki a b c option is a simple function and d means ki all the above function is actually a simple function. Okay, that's all the order. Try to solve this problem. In this problem, it is saying that there is a probability space and there are events A and B which satisfy PA is equal to PB is equal to zero point 0.5, means probability of occurrence of A is equal to the probability of occurrence of B is equal to 0.25, and probability of A union B is equal to zero point 0.3. You have to compute the integral of B 1a dp. Okay, try to solve this problem. Okay, let me give the solution for this. When you see that key, what is asking? Okay, so when you say that integral of 1a, that is dp, simply equal to 1a 1b dp, that is simply equal to probability of a intersection b. Okay, so probability of a union b is equal to probability of a probability of b minus probability of a intersection b. So probability of A intersection B is simply equal to probability of A union B minus probability of A minus of probability of B. Okay. So when you say that A union B is already given, that is zero point 0.3 minus what is probability of A, that is both is equal to 0.25 and 0.25. Okay. When you see that that one minus probability of A union B minus probability of A minus probability of B. Okay. Let's solve it. When you see that point this okay, so this will be minus. Okay, minus here. When you solve it, it will be minus zero point 0.3 minus zero point 0.5. It will come out to be zero point 0.2. Okay, this is zero point 0.2 is the correct answer, so option B is the correct. Okay, let's try to solve this. Here is x is binomial distribution in NP. It is being asked that what is the expectation of x. This we have already solved in the previous tutorial session, but I wanted you to remember it and try to figure it out whether which option is actually correctly matching. Okay, let me give the solution for this. It is being said that x is the binomial distribution n in P. What is the expectation of x? Okay, when you see that it is simple, very simple problem. The expectation of x is already being computed with the np. Okay, the option A is correct. That is already been defined by the and derivated by me in the previous tutorial session. You just have to look into that, and if you feel still you having doubt, just let me know. Okay, in the next tutorial session. So we have discussed few of the problems. Slides having more problem, but that will we will see in the next tutorial session because the time is constant is there. Okay, and if you feel that any doubt is there or anything which can be improved in that, just let me know in the tutorial next tutorial session, or you can write it to me. Okay, thank you so much for joining for today's tutorial session. Have a good day.